It's all there. We make all the new timing gear for it, the billet cam cover with the coil kit, integrator trigger kit, and all of a sudden we've got a $15,000 engine package, make 1,000 horsepower on a KA24 engine that you can pick up for $300. That's where we need to be. Forget the SR.
Welcome to the HPA Tuned In podcast. I'm Andre, your host, and in this episode, we're joined by Herman from Platinum Racing Products in Australia. Platinum Racing Products are well known for producing parts that really walk that tightrope of both form and function. What I mean by this is parts that do the job they're designed to do, but also look amazing while they're doing it. And let's be honest, as car people, we like to make our cars look better when we're buying aftermarket parts that improve the performance as well. So why not have both? In terms of some of the parts that they produce, I'm talking here about billet rocker covers, I'm talking about cam angle sensor replacement kits, crank trigger kits, RB26 four-wheel drive sump adapters for RB30 blocks, and the list honestly just goes on. One of the products I was really interested to talk to Herman about, though, is something that they've been working on for a while now, and it's an up-and-coming product. I think this is going to change the game, and this is their cast alloy RB26 block. I say cast alloy, they actually haven't decided yet whether it's going to be cast alloy or cast iron. But either way, it's interesting in a world surrounded by aftermarket billet blocks that Platinum Racing Products have decided to go down this path. But you don't have to wonder why they're doing that for long, because if you listen to this interview, you'll actually learn that there are some distinct and significant advantages with a cast block over a billet block, up to a certain power level at least anyway. On top of this, they're also producing a replacement cast head for the RB26 that's going to fix a number of the problems, one of them being that you can't actually buy new head castings from Nissan, but this also improves the port flow and a number of other shortcomings in the factory head. On top of this, we dive deep into the design process, how they're using 3D modeling software and CNC machining equipment in order to make these parts, and some of the processes and considerations around this to make these parts that are actually going to be time and cost efficient. So really great interview with Herman. Lots of great information in this one. Before we jump into that interview, for those who are new to the Tuned In podcast, High Performance Academy is an online training school. We specialize in teaching people how to tune EFI, build performance engines, construct wiring harnesses. We also cover topics on race driver education, race car setup, data analysis, and fabrication. You can find all of our courses at hpacademy.com/courses. They're all delivered via high definition video modules that you can watch from anywhere in the world, provided you've got an internet connection. And as a podcast listener, you can use the coupon code podcast75. That'll get you $75 off the purchase of your very first HPA course. And we'll put a link to that coupon code in the description. All right, let's get into our interview now. All right, welcome to the podcast, Herman. Thanks for joining us today. And as we always do, let's get started by learning a little bit about your background. Specifically, how did you get interested in cars?
I've been a car nut ever since I was an apprentice mechanic at a truck machine shop. It was actually a mechanic shop. They did a little bit of machining there, but I was just a mechanic as an apprentice. This guy came in with a Toyota Sora, like the old MZ70 version Sora, twin turbo thing, 1J. And I was like, wow, that thing's amazing. Anyway, we got talking and I sort of ended up, cutting a very long story short, going into business with that guy importing cars out of Japan.
Wow, that accelerated quickly.
Absolutely. Now, that was probably back in 1995 or so. You know, I was still working as a mechanic. I still did my apprenticeship. All that sort of stuff happened. I got qualified quite a lot earlier than the 4 years. But yeah, I was a truck mechanic. So then we went from that very quickly into importing cars, and that led into car yards. It was called NV Imports at the time. We were doing deals with big companies in New Zealand and in Japan quite a lot, importing a whole heap of cars, and that sort of led into compliance, which is what led into my engineering background of, you know, aftermarket, Department of Transport, compliance, plates, personal imports, low volume, raws. It all sort of led eventually into full volume compliance as a new manufacturer with left to right conversions on American pickup trucks, cars, sports cars, Corvettes, all that sort of thing, the Dodge Rams, the F-250s, that sort of stuff. But in between there was a bit of a gap where we went from car sales into dyno tuning, and we called the Envy Import Shop, branched off into Envy Dyno. We put in a dyno, Dynamics dyno. We started doing dyno tunes and building engines. And because I was always passionate about the imports, especially the GTRs, I started building a lot of RB26s. So we're talking the early 2000s. I think probably first sort of started getting into building RBs in 1999. And I remember building a car for a particular person who's been around in the game for a lot of years. He had one of the first RB30s in the country, and he loved this thing. It was making 400 odd, 500 kilowatts. Back then it was a heap of power. And I remember he came in one day, Herman, I want you to build this engine. Cool, no worries. We pulled it apart, and it had this weird adapter plate on the bottom of it. This is garbage. We can't run that. And he goes, no, that's all you can do. I go, no, that doesn't work. It's there's nothing holding the main. This could be a lot better. I said, Herman, nothing exists. You've got to use that or come up with something yourself. Do something different. I don't care. And that's sort of when the first Platinum brace came about. Yep, sort of TIG welded, mild steel sort of contraption that looked vaguely similar to what we started producing. And that ended up leading into our brace. So, yeah.
So that was the first PRP product?
Absolutely. So I didn't get serious until much later. But yeah, the dyno tuning, all in engineering. I became an aftermarket engineer, doing engineer certificates and all that sort of stuff. So that was the background. And then always had this eager passion for the RB, regardless of the business that I was in at the time, you know.
Okay, that's a hell of a lot to unpack there, but let's give it a crack. I'm interested because it sounded from what you were saying there that you were already reasonably deep down the path of this truck mechanics apprenticeship before you actually kind of got the spark lit and became an automotive enthusiast. Now, if I'm picking that up correctly, I'm interested, if you didn't really have the passion for spinning spanners, what led you to that as a career path early on to start with?
Always had the passion for spinning spanners. I was always in a motocross building my own dirt bike engines from an early age, 16, 17, I was pulling engines apart and dad's lawnmower and not being able to put it back together and, learning as I went and modifying my dirt bike and putting bigger wheels on it and all this sort of stuff. And my old man, I remember he told me the story the other day. He's like, just hated the motorbike thing, and I said, I'm going to change the wheels. I want to go to from a CR80 to a big wheel so I can race against the bigger guys. And he's like, yeah, do that. That's a great idea. You'll never get that back together. I learned how to weld, and I made all these wheels happen. And he was like, shit, okay. And that led into more of a motocross sort of, enthusiast background, racing and all that sort of stuff. And I learned because I was interested in it. I made it happen. And I was always keen on spinning spanners, and I loved big engines. I wanted to build truck engines. So I got into that. But then when I saw that there was this whole, hang on, there's a performance thing and cars can race with engines that I know how to build in trucks. It can't be that much different. Started importing, and the car sort of scene was going nuts, and Fast and the Furious came out not long after that. And I sold out of all my GTRs and Supras. It was like, all right, I think this is what I really want to do. I don't know about for the rest of my life, but I love it. And started building engines. And then once I learned how to do some, basic tuning, we sort of developed the tuning shop, and it all sort of went gangbusters from there, man.
All right, let's talk a little bit about the tuning side of things. I don't want to dwell on it too much because PRP is obviously going to be the core of our discussion, Platinum Racing Products, for those who maybe have been hiding under a rock and haven't seen the brand. I've come from owning and running a tuning shop, and HPA was founded to teach people how to tune because there is such a lack of knowledge out there. So I know how difficult it is to just wake up one day and go, hey, you know what, I'm going to start a tuning shop. And to be able to do that and do it successfully is no mean feat. So give us a quick overview of how that developed, how you learned those skills, what the stumbling blocks or problems that you faced were as you did that.
Yeah. So look, from having to get a car built and an engine built, and this was around the era we really went gangbusters with our own dyno, was a car called the Jetta's Edge R34. Now this car sort of ended up going viral with me driving it barefoot up and down the streets, the local streets here, with a passenger in the car, a mate of mine, Mr., who was just like swearing and giggling. And this is the kind of guy that you can't get that excited about anything. And he was just like, I've never felt anything like it. And that video just went gangbusters. So it was around that time. It would have been, I don't know, 15 years ago, 12, maybe 12, 13 years ago. But anyway, we were tuning. I had a really good tuner working for me, and he was showing me the ropes on how to tune, and I was getting my head around VCM tunes for Holden, Commodore VE type things. Got my head around niche tunes, and I started soldering in the boards, doing the basic tunes, and I was, 300-400 kilowatts. I was good to go, and obviously when you start doing bigger power builds, it almost gets simpler because you're sort of spending more time on, you do your light cruisers and all the rest of the stuff, and then get into the power, and you're just adding boost basically and keeping an eye on timing. You might be changing fuels or whatever. Getting the car to cruise, as you know, start, idle, the cold, the low end sort of stuff, the cruisers, the cold starts, all that sort of stuff, dialing in injectors and getting all that sort of stuff working. That's the hard part of the tuning. And yeah, if you're good, you can do it really quickly. And if you're learning, that can take you weeks to try and work out. So I was by all means doing the simple tunes while my mate and worker, Brent, at the time, who's still in the game tuning, he was just, it didn't matter whether you threw him a Motec or a Link or a whatever, he was happy to tune it. So that's where all of that happened. But I was also running the shop. We had an engine building room. I was building all the engines. We had 8 hoists, 5 or 6 mechanics, and we were trying to pump out work. And that's sort of where I learnt that, there was a massive market for parts because you're making and fabricated absolutely everything that had to go into a build, because you couldn't just buy something off the shelf. And then obviously it would progress into the dyno tuning, but there was a market there for, it's a really hard game to run a dyno tuning shop. And I'm sure you know about it, especially a performance mechanic shop. It's hard.
Absolutely. Yeah. Rewarding when it goes right, but yeah, it is a tough game and the expectations are set very high. I mean, particularly when it comes to the full builds, you've got a customer who wants a 800 horsepower 4G63, for example, and there's a certain number of components that all have a fairly high ticket price that go into a build of that nature. And at the end of the day, the margins on these are slim. Quite often, the customers can buy the hard parts for the engine at or below the price that some of the workshops pay for them. So the margin isn't there. So you're really only making the money on your labour, maybe a markup on a few bits and pieces, but you're not making thousands and thousands of dollars on this $20,000 engine build. And then one single thing goes wrong, and you're holding the can for what is going to be a very expensive repair. So it's, yeah. And I mean, the best laid plans, things still go wrong no matter how careful you are, no matter how many times you double check things. So it's a difficult industry because when things go right, there is a small amount of money to be made. And when things go wrong, you go backwards real fast.
That brings me to one of the reasons I ended up mass producing parts. You would go and prototype a part, make a custom one-off, and that would be the end of it. And I realized that, hang on, why am I just making one of these? If I do all the hard work, get this engine, at the time, I can remember the actual moment when I started having these thoughts. It was putting a Barra engine into a Patrol. Now, I know it's been done probably 1,000 times since, but I was probably one of the first. And this happened in 2012, the Christmas into 2013. I had all my staff away on Christmas holidays, and I was stuffing a Barra engine into a Patrol, and I was fabbing up the exhaust and everything like that at the time. And we made a, gearbox conversion, bell housing conversion, air conditioning, power steering, all that crap. And I was just fabbing up the exhaust, and I was there by myself, and I had to get the job out so I could pay the rent. And I'm there. I've got, my stands and everything. You can picture me under the car, all these stainless bits. I've got the little pie cuts and everything sort of balancing in the right spot, holding a muffler with one hand, jack stand, gearbox stand, all that shit. Grab my welder that's over my shoulder. You close your eyes to do a spot. Nothing. And look down, and the earth strap, it's on the ground. And at that time, it just all fell, and it hit me everywhere. I got a lump on the head. I lost it. I was panicking, furious, crying. It was just all flowing. So at that point, I just thought, you know what? This is just not the right way to do this.
Got to be a better way.
There's got to be a better way, man. Why just not do this once?
I couldn't agree more, and I've been in the same situation, or similar situations myself, and I think this isn't to sort of put off all of our listeners from other parts of the world, but I do class that New Zealand and Australia, we have a very similar mentality when it comes to building cars, and that mentality is that we'll just jump in and make something. if there's nothing off the shelf, we'll just get it done and we'll find a way. And that's, again, not to say that this doesn't happen around the world, but I do see a very different mentality from other countries where, at least from a mainstream perspective, the guys and girls building the cars just want to be able to tick a box, pick the part up off the shelf or have it delivered via UPS and bolt it to the engine or the car or whatever, job done. And I mean, I can't argue with the fact that it's really nice when you've got that option, and it's even better when the part that you actually spend good money on is high quality, fits like it should, and does the job that you're expecting. But it's a very different mentality, I think, between making do, doing a one-off yourself, and then going to that length of mass production. And I think it's like, not everyone's going to join the dots like, hey, I needed this one-off part that I've just spent a day fabbing up and making this one-off. So if I needed this, well, what about we actually go a little bit further, put a little bit more time or effort in, and now we can make 100 or 1,000 of these and sell them for a profit. Coming back, you said that lower girdle block brace or whatever, well, that was kind of your first foray into it. So
conversion for four-wheel drive thingy, That's sort of where it happened.
So that's the difference between the RB30 block and the RB26 block. When you want to use the 30 block in a four-wheel drive setup, the four-wheel drive sump will not bolt to the 30 block.
That's right. You're missing a whole set of bolts on the pan rail, the M10. So, yeah, you need to adapt it somehow.
Okay, so I mean, there's still got to be quite a long journey between that and where Platinum Racing Products is today. So how did that sort of develop to what it is now?
Well, look, that brace, for example, we did it at the same time as our first cast bracket, and it was just, nothing really other than looks, because it didn't need to be strong to support a mechanical fuel pump or anything at the time. It was just a pretty bit of bling, and I just wanted it for my own car. Most of the stuff I was making was just because I wanted a nice one for my own car. Everything else looks nice and shiny, cam gears and all of it. What about that little crappy bit of die cast, aluminium on the front? So it was like with the brace, I remember a machinist that we still anodise for, he's still a good friend of mine. I said, he came into the shop once and he saw this metal contraption that I'd made, and he goes, "What are you doing there?" I go, "It's a main cap brace, and I've worked out it can do a four-wheel drive adapter, and it's going to tie in the mains and stop them moving and do this and maybe help with a bit of block twist." And he's like, "That's fantastic. Why don't we make a billet one?" I'm like, "Oh, you reckon?" He goes, "Well, you going to run that?" I said, "Yeah." He goes, "Well, why don't we, do you think you can sell them?" I, "Maybe." So we made a prototype, and then that ended up going on that engine. I did the instruction manual and all that, and I'm going, "Okay, mate, I've got a few people kind of keen. Can we make a batch?" He goes, "Well, yeah, how many do you want to make?" I'm like, "2?" He's like,
"That's not a batch."
3? And he goes, "I'll start with 3. 3's okay, we'll do 3. And then I was nervous, like, am I ever going to sell those 3?
Yeah.
Same with the cast brackets, we started with 5. Am I ever going to sell them? Now we do batches of 500. So, yeah, the engine braces, it was like I was nervous, and slowly, it took years for it to take off, and I went into the car conversion game, left the mechanic scene, left Platinum. We were doing mass production, left to right conversions in the Philippines, bringing it over. And anyway, all that sort of, it was just really stressful that it didn't work out because we lost, 10 containers with a Hanjin shipping company that went bust at the time, and it was just all too much. And all that went downhill, and I just decided to start working on what I love doing, which was back in the RB scene. So you know what? I'm going to go Platinum full time. So I did, and it's turned into what it has today. We were outsourcing everything at COVID, and I was using every local shop that I could in Australia. We were outsourcing, to Hypertune and all the rest of it. We started to make braces, and it was only at the time, I think Jun 2 ran one of our conversion braces. I didn't even know about it, from CRD, and they went and ran a record and another record. They got down to the low 722 with our brace. All of a sudden, it started getting really popular. The demand started to increase. We're doing a little bit of Facebook not even marketing. I'm just a Facebook page, and we started up an Instagram after mate Dartone Racing. "Hey, you don't have Instagram? Start up an Instagram." I mean, we're talking 5 years ago now. All that started to happen. Hypertune was making braces, and it was all like I needed more. We started contracting a few other machine shops. We're working, trying to get stuff out of China. All that was a nightmare. It's just Billet was getting hard. It was just all too hard. And because of COVID, 2020 or whenever that started happening, the end of 1920, whatever it was, I just couldn't get stuff made anywhere. And everyone was in the same boat. everyone was going out of business, and there was heaps of machines coming up because Holden, Ford, everyone was closing down, and all of a sudden there's an influx of all these machines, and I'm like, you know what? Let's buy a machine.
Bite the bullet and do it.
Yeah. So that was the first machine we bought there, yeah.
I'm interested in diving a bit into this because obviously CNC machining equipment can be horrendously expensive. And I think it's fair to say that the way you're operating is probably the way a lot of similar companies at least get started, where they're doing the design work, they're doing the development work, the testing, validation, and they're relying on outworking the actual machining. Now, when you compare that to buying your own equipment, obviously the cost of the equipment is one element that we need to consider here, but is the saving then in the production costs the element that you're looking for? Basically, each part becomes cheaper to make because you're not paying a markup to someone else? Or is it more along the lines of having complete in-house control of the production?
Yeah, it's control. It's definitely control. Costs come down eventually when you dial it in, but what a lot of people don't realise, and what I didn't realise at the time, you put in a CNC machine and then turning it on, that's not all that easy. And then you go, oh, hang on a second, you need to design something and it needs to be a particular file type, then you need to be able to post-process it. So you need separate software to post-process it. And all this stuff is really expensive. The design, if you're running Fusion or whatever, you're running SolidCam, you're running SolidWorks or any of those, there's a heap of different softwares available. That's really hard to use if you've never used it before. So finding a machinist that knew how to do that was the main thing, then being able to tool the machine up and get it to not sit there for a year, which is what a lot of people do. I've seen machines, I've gone and bought secondhand machines. There's like a brand new machine that's never been used, and there it is 20 years later and no one worked out how to get it running. It's not that easy.
Is that simply because someone's gone and bought the machine thinking, yep, we'll have this up and running tomorrow, and then they realize that they don't know what they don't know? There's a huge other part of the knowledge and cost involved.
Absolutely. And more importantly, someone will go, I want to get into CNC machining. They've got no parts. They just buy a machine and hope that all of a sudden it generates work. It doesn't work that way. You kind of need to outsource your stuff to a point where you need to start making the decision on whether or not you're going to buy a second-hand machine, because you're not going to go and buy a brand new one like we do now for $1 million. You're going to go and spend 20 grand or 30 or 40, and it's going to be a ratted out old machine, and you're going to go and crash it a few times, learn, or put on a machinist, and it's not ideal. And for a part that you might need to, might have 5 or 6 or 8 different operations, you've got to turn that part 8 different times to get all the angles to machine the bits that you want to do. Different now on a 4 or 5 axis machine. You can articulate it and interpolate it to get all those finishes. But when you're starting off and you've only got one machine, you've got to do everything on that machine. So yeah, it's a huge learning curve. Absolutely.
On that aspect as well, now you've got everything obviously pretty well dialed in. You've got a large product range, and I mean, you just alluded to the fact your run numbers are getting up there. Is it sort of something you focus on, trying to have your machinery running 24/7, or is that not really viable?
All machines run. We basically run at the moment. We will go back to running 24 hours a day, but at the moment we're running probably 21 hours a day, 5 to 6 days a week. We're waiting for some more staff to come along to go and kick it back in overdrive 24/7. But yeah, absolutely, the machines can't sit, and we've got every machine backed up for 6 months usually or so. And we just put basically everything that we're running out of is, that ends up on a list, and it starts to change colors as it gets more urgent. And then we go into, if we've got a machine issue or we're waiting for it or we're just overwhelmed with work, then basically it's like, okay, we've got 34 of those sold, 22 of that, 15 of that, whatever, and we just go, right, what's going to make the most amount of people happy? That's running on that. And sometimes it'll go really well, and you get the next one and 4 or 5 machines, and you can catch up in a week or two. But other times, if you're prototyping, a 4-wheel drive dry sump, and you're running each separate part on a separate machine to get the prototype together because you finally spent 3 years, designing this part and put hundreds of thousands of dollars worth of time, effort, labor, and you've got a prototype that's about to go on June 2 when they're racing next weekend. It's like all hands on deck. Everything else kind of needs to stop to get the project done, when we've worked with daily engineering for a year to get a custom pump sort of made. And, I've got 10 billets there that was, $25,000 worth, and the pumps were $60,000 worth. And like the project's got to go. You finally stop everything, make it happen, upset a bunch of people that are waiting for stuff, promises get stretched, and it's just like, even with, I think we're running 15 machines and 20-something staff, you still get to the point where everything gets pushed and everyone gets exhausted and tired, and you do finally get it together, quickly finish it, button it, the prototype's done, everything can rest, catch up on everything else, keep everyone happy, pull it all in, breathe.
And do it all again.
And start again, man. Yeah, it's relentless.
So it's interesting because I've just literally gone through this trying to chase down some parts for one of our race cars out of the US. And I mean, it seems like everyone I talked to recently, the lead times on parts are still just out the gate. I'm talking a dry sump kit, and it actually was from Daily, and he's talking sort of a November delivery time, and we're recording this the beginning of May. And I'm sort of thinking, this was the norm over COVID, and we're now sort of 3 years out from this. Where are the stumbling blocks? What are the sort of bottlenecks in the system? Is it the machinery sort of headroom that you need more machines? Is it staff, or is it the materials, or is it all of this?
It's all of that. Material can get hard to get, but if you're, for example, we'll go and machine all of our parts. We try and do a run calculated to run us 12 months worth. So we'll go and put 12 months worth of stock on the shelf, so we don't have to go and tool the machine up. Sometimes with a mill turn machine, for example, you're tooling it up for 3 days and then it'll run for a day and you do 1,000 units or whatever it is, especially on an automatic bar fed machine, So it's like, you've really got to plan. Short runs kill you. Prototyping kills you. Doing jobs for other people kills you. So now we just simply don't take on work unless it's something that we're doing for a partner that we get to on-sell as well, because the money's just not there in it. But yeah, all of those things, factoring in dry sumps with Bill Daly, for example. I mean, we've got orders in at the moment. We're putting in orders. We got 10 pumps happening every month. September, October, November, December's booked, and we're trying to up those numbers. But even if you go and add in an extra 2 pumps on a September order that was booked 4 months ago, it's a problem, and you've got to pay fees to get overtime staff at Daily to get those pumps done because they're so under the pump. So it's like, I could be telling Bill, this is going to take off. Have you made one yet? No, we haven't made one. He goes, how come you want 50 pumps? It's like, it'll take off, Bill. Okay, well, whatever, all right. And then all of a sudden.
So then the problem you may end up facing is it takes off even better than you expect, and then you can't supply because they can't supply pumps, which leads me to something I was going through my mind as you were talking about that. I mean, I can only imagine that, Daily Engineering have an exceptional name for building some exceptionally high quality dry sump kits and the pumps, no question about that. But I mean, it sounds to me like you've probably got all of the capabilities in-house to build your own dry sump pumps if that's a path you want to go down. Again, sort of coming back to what we were originally talking about, where having control of doing everything in-house gives you an advantage. Was that not worth the learning curve of figuring out all of the problems that you'd have to overcome with designing a dry sump pump?
Yeah, look, it all comes down to building alliances, doing deals, and honouring them, not going into competition with someone that's helped you make a preliminary version of whatever you're making. Now, pushing on their marketing, because obviously Daily, we don't have to go and compete against them. We can incorporate them. The brand speaks for itself. It's on every second NASCAR, whatever, all the circuit stuff, the touring car stuff all over the world. It's a given. So we don't have to market and try and convince people to try something new. It's like running a Kinsler fuel pump. We're the biggest dealer in the world for Kinsler. I've met Jim Kinsler several times. We're friends. I asked him, hey, you know what? I want a 24-gallon pump. You're going to have to make me a tough pump from a 1,600. I want to go a 2,000. Herman, for you, yes. And they might have said no 4 times already, but Herman, if you really want it, we'll do it because, you're the biggest in the world for it. So we can't do it all, and we're already backed up 6 months. And every time I buy it takes a year to get a new machine. By the time it hits the ground, and we installed 2 last week, they're already at capacity and booked for 6 months. So because we've got so many projects going on and we're trying to wrap our tentacles around so many different areas, and we want to be able to offer a complete RB in parts from crank to cam covers, sumps, manifolds, the whole lot as a turnkey for a mechanic to go and just assemble, final machinist, and we'll get into that in a minute. We can't do it all. So we work with the guys that do those other parts, form really good alliances. Everyone makes money. We turn it over. It's just like we need them as much as they need us. And man, it's crucial.
I think it's smart to recognize that, and I guess for want of a better term, stay in your own lane, understand what your own strengths and weaknesses are, but more importantly, understand what the strengths and weaknesses of these other manufacturers are and leverage that. Like you say, I mean, the reputation of something like a Daily Engineering dry sump pump just goes without saying, and yeah, that can be smarter, even if you are giving away a little bit of that control on the front end.
On that, a saying that my mate from Ben at Artec Manifolds, we do a lot together. We've become really close. He always says the same thing, and this got handed down to him, I think from Ian World Time Attack years ago, and I'm quoting 20-year-old saying, can you make a cheeseburger better than McDonald's? And if you can you sell it better than them? Can you market it better than them? Have you got the reach that McDonald's has got? If the answer is no, just buy a McDonald's cheeseburger and put it in your own kit. You know what I mean? Yeah, just go and buy a Happy Meal and be done with it. Or use them or work with them. It's like alliances with TurboSmart. Can we go and make a wastegate? Yeah, sure, we can make a wastegate, no problem. It can't be that hard. But dealing with Brendan at TurboSmart on a PRP gate, and if you don't work with me, I'm just going to make my own, you prick. And he's like, no, forget all that. We'll work with you. What do you want? I go, I just want colors, bro. No worries. We can work with that. And it's just like you build that alliance, and then you're in business together, and then the next time something happens, hey, Herman, and you don't step on each other's toes for that reason, because you've got those alliances, but you're already working with someone that's done 20 years worth of R&D on an oil pump or a fuel pump or a wastegate. Sure, you can learn it all, and you can learn it all quickly, but why if it already exists? There's a gap in the market if someone's doing a crappy job, and then you might go and do a better job because there's a necessity, but that's different, right?
Yeah, that's very different to competing against an existing developed and quality product. Yeah, I mean, there's dealing with trying to make a better product compared to something that's a pile of garbage. That's a very different deal. Now, in terms of that very sort of similar direction here, what I do see for a business like your own is potential risk involved with protecting your IP, because at the end of the day, intellectual property I'm talking about here, because at the end of the day, you're making a hard part that someone who wants to copy it at the end of the day could just buy one off you, get it into their own hands, and then reverse engineer it and make it basically the same, maybe tweak a dimension or put a scallop or a chamfer on something to say it's different, and then they're up and running. They've shortcut all of the development time and expense that you've put into it, and are basically selling the same product, maybe in a different color. How do you deal with that? Is this just a cost of doing business in this time and day?
Yes and no. It used to really get under my skin and bother me because it was burning. But when people are starting off, they might not have the capability to go and engineer their own. So reverse engineering something that someone's already made, I get that, and you've all got to start somewhere. Now, going from that and having no market, no capabilities, and just having a go and starting somewhere, I respect that to a certain point. Going blatantly copying someone's shit, I mean, it happens. But if it's a stepping stone to something else, one thing, if you're already an established company and you have a market in a certain area, and you just go and copy someone else in the market that's doing a really good job of a particular part and copy it verbatim when you don't have to, or send it to China and get it copied and then compete with the person that you were probably already doing business with, or you're in the same arena, I mean, it's disheartening. It hurts every time. It doesn't get any better. I always say, if you can make something better than what we make it, and you can market it better, sell it better, give enough of them away in the right areas to get the right attention when it comes to social media and YouTubers and all the rest of it. If you can do what we do better than us, go for it. If I then outdo that product by making it better and doing all of that stuff I just mentioned better again to retain my market share, well, then I will. But there's not much you can do to stop someone sending your stuff to China, and it happens heaps. I mean, every week there's someone that's gone and copied one of our products, as well as a Hypertune or a Plasma Man or whatever, getting copied, and it's a problem, and you just can't get down about it. You've just got to move in with all of your own ideas. And I've said to some of the guys before, why copy that idea? If you're stuck for an idea, bro, I'll give you a CAD design on one of the 500 products we've got sitting waiting for machining, and you go, good luck to you. I mean, don't copy mine. Just come up with something else. If you want to buy our one, or you want to, work with it, come and see us and say, listen, I want to buy 1,000 of that product because I want to, use it again. Man, we'll co-brand it. I don't care. We'll work something out. But it happens heaps, and it's a problem. And how to fix it, You just got to hold your head high, keep doing what you're doing and not let it bother you, because it'll impact the way you do business in a negative way, and you just can't have that sort of stuff hold you back, really.
A couple of things about that. I think there's two very different elements here. That there is a blatant copy, and then there's what you were talking about of an iterative improvement. You can see a product and maybe you've used it and you think, hey, I really like this product, but I think it could be improved by this, this, and this, and then you make your own product. That's somewhat different. I'm talking more about the send it to China or wherever that may be, and it is literally a blatant copy. I've got no time for that. There's a couple of elements though. One that I've never been able to get my head around, because I've seen my share of blatant rip-off name brand components out of China, and I'm talking typically it'll be something like an HKS blow-off valve or maybe a HKS external wastegate or something of that nature. And you literally have to go onto HKS's genuine site and look at their scam copy to work out it should have this little thing in the top right corner of the packaging, and if it doesn't, it's a scam. And you're like, they've gone to that much trouble. Other than that, looking at the product, it'd take a professional to know at a glance which is which. So they've done all the hard work and got it looking physically identical. Why can't, because often these things then fall apart the first time the car comes on boost. Why can't they just finish the job and actually also produce a part that actually works properly? That's the bit that always blows my mind.
Or make their own,
Or that. And the other element that I wanted to mention here is that it kind of comes down to what you were saying there, your 500 product designs that still haven't actually made it in production. One thing that I always sort of keep in mind in that situation where someone's copied something we've done is like, well, yeah, that's great. You've copied that product that we produced 5 years ago, but you've got no idea what's on the drawing board. The people copying will always be 3, 4, 5 steps behind. So I think I take pride in keeping that in the back of my mind. You can't copy ahead. You can only copy what's already been done, and they're always just going to be lagging behind.
On that, we've gone so far out of our way to make parts really hard and really expensive to copy. I can give you 1,000 examples here, but our bottom crank gear, we do them in one op on a mill turn, and used to be 8 operations with different parts that you'd coin together and all the rest of it. So making it hard to copy without a $500,000 machine or $1 million machine on a 5-axis or whatever, we've introduced as much of that as possible, as well as making it look a certain way. And it doesn't just have to complete its function. It's got to hang on, my designers do it all the time. All right, I made a new fuel rail or whatever. Yeah, but that looks shit. You've got to make it look cool and go with the brand, and we're going to do it in all our colors. And how can we make it? It's really expensive to make it that way. It's an extra machining op. Doesn't matter. It's giving us a point of difference.
That was going to be my next question, because all of these parts, they're there to serve a purpose, clearly, and that's their number one reason for being. But car people, we want our cars to look good. When we're going to spend $500 or $1,500 on a part, it's not just about it serving that function. It's about it also aesthetically looking good. The form and the function have to go hand in hand together. So how do you sort of balance that out? What's your priority there? Is it function first and then form? Or how do you judge that?
Yeah, look, it's always function first, and you do your testing and your scoping and your whatever data or testing you're doing on whatever machine and however you're doing it, and you come up with a raw concept. And once it's proofed, we do some testing. We're happy with how the product's going to work. Then we're like, okay, now let's redesign it, make it look cool. But, I'm not going to say that we don't go out of our way to make our stuff look spectacular, other than the, quality of the machining. We want someone to go and put one part, whether it be an oil cap or a trigger kit or whatever, in their engine bay, and then, now the rest looks crap.
It's a slippery slope.
Yeah, absolutely. We want you to buy more parts. But just to skip back a bit, because there's a really important point I wanted to put in about the copying, and it's an issue more so when someone goes and copies a manufacturer like ourselves or Garrett or whoever, and it happens a lot, HKS as you mentioned. You're actually buying a copied part and taking profit of that part, competing against the manufacturer, taking the R&D funding out of, or the wind out of the sails for the manufacturer that's actually developing the new parts. So when someone goes and buys a copy PRP, whatever, right? It's taking money out of the pockets that's obviously we put everything back into the business to R&D, new blocks and engines and whatever we're doing. So it's like with Garrett, for example, yeah, you can go and buy an Alibaba copy turbo for $50, but it's actually taking out of the guys that are manufacturing and developing and R&D new stuff, new turbos, new technology by buying the knockoff. It's just counterproductive. So when we get support people buying our products, of course, it's all going back in and we give back because it does. We've got a whole heap of parts that are being designed and developed, and we need the money and the funding to keep the cash flow moving to go and make new cylinder heads and blocks and stuff, which we'll get into later. It does. It bites the hand that feeds you because everyone wants all the cool new tech. You've got to be willing to pay for it to fund more cool new tech, So that aside, yes, the parts have to look the part, and a lot goes into making them look good, and sometimes we'll go and revise a part 16 times for functionability or the look or aesthetics, or develop it into, incorporating some new technology. But you can't be afraid to obviously revise, update, and change a product and make it look cool because people are sticking it on their pride and joy engine bay, and it just has to look killer in whatever color they want. You want green. It's not, from a sales point of view, having 12 different colors in your arsenal is the worst thing that you can do for having to stock a whole heap of stuff and your dealers and everyone. I've been told by big dealers overseas, you got too many colors, it's all too hard. It's like, yeah, but...
That's your point of difference.
Well, yeah, you got a green car with a green engine. Who are we to tell you can't have a green oil cap, man? It's like, you should be able to buy what you've got. Everything's red, and sorry, we can only sell you a purple cam gear. It's like, but they clash. Red and purple, they don't go. It's like, sorry, mate, it's purple, purple, or purple. No, you want to have green, you want to have blue or teal or gold or what, a rainbow the thing for you. I don't care. It's got to look the part, and I think it's important.
Yeah, no, I totally appreciate that. I just wanted to take a moment out of our interview with Herman and talk about a course that I think, if you've enjoyed our podcast so far, would be really well suited to you, and that is our Engine Building Fundamentals course. I know for a lot of enthusiasts, they're prepared to do just about any aspect of their project car build, but they'll shy away from the engine building side of things, thinking that this is a task that just can't be done by the home enthusiast. Well, our Engine Building Fundamentals course is there to prove that this is not the case, and actually any home enthusiast with an eye for detail and a little bit of patience can actually do a great job of assembling a performance engine. With the help of this course, you'll learn what actually goes into building a performance engine. You'll learn about the machining operations that are essential to building a performance engine. You'll learn which operations are going to be required for your particular engine and maybe where you can save a little bit of money. This is important because it also allows you to speak the same language as your engine machinist, and you will definitely be needing to lean heavily on an engine machinist to do some of the heavy lifting of the engine building process, which is machining all of your hard parts prior to assembly. You'll also learn about the tolerances and clearances inside the engine. You'll learn what these are, what they mean, how to measure them, and most importantly, why you may need to vary the clearances from what the factory recommend for an engine that's going to be making maybe 20 to 50% more power than stock, and maybe it's going to rev 1,000 RPM higher than the factory rev limit. This course is available using the coupon code PLATINUM50 with a 50% off the normal purchase price. We will put a link to this course as well as the coupon code in the show notes to make it super easy to find. Even with that coupon code, you are still protected with our 60-day no questions asked money back guarantee. So if you purchase and decide it's not quite what you wanted, maybe not what you expected, no problem. Let us know. We'll give you a full refund of the purchase price. All right, let's get back to our interview now. All right, let's come back to the design side of things, because the technology we've got available now, 3D modeling software, CNC machining, while obviously they're definitely not brand new, the availability or access to them has become greatly improved, and this is why we've seen this sort of massive sort of exponential growth in an industry of these sorts of parts. It just wasn't around back when I was building my old drag car. So how much of a game changer has this technology been in allowing PRP to do what you do?
Okay, so look, to give you an example, when we first started making a coil bracket for a JZ, for example, there'd be 20 different revisions, shaving them off with a die grinder or a belt minister, trying to get it to fit, and then, working different solutions and revisions to try and make it all work, and then having a finished product that you go and find there's a different style of head and then it doesn't fit. It's like, it's so much different because you can scan it all in and you build the part into the model. And now, for example, we have a whole RB engine built in a model on a CAD with the Arctic exhaust manifold and the Garrett turbo and everything. And basically, we've got the whole engine bay scanned in, and we can put it in the car, build a dry sump system, know where it already fits. And by the time you're actually prototyping it and making it, it's come a long way. But to safely say now that we can physically use a first production run, let alone the prototype, it's come a long way. I mean, it's outstanding. The quality of the software and how it integrates in with scanning software and modeling software to a post-process part, it's leaps and bounds away from, even in the last 5 years, of where we've come from.
Definitely one of the elements that I've seen ourselves with our own 3D modeling course, and we've just recently bought a Peel 3D scanner, is the price of 3D scanning technology has just massively come down. I mean, obviously you can still spend huge amounts of money for super precise equipment, but that Peel 3D scanner that we're using, I mean, it does a stand-up job for the price point. And I mean, even to the point where in our course we show how you can use an app on an iPhone in order to essentially get something that's not going to be precise to a tenth of a millimeter or better, but depending on the part that you're producing, obviously it's essentially free technology if you've already got an iPhone, and it'll do a really good job. And then again, as you've mentioned, having that confidence to build everything in CAD and test fit and know the clearances to cross members and chassis rails and all of the other ancillaries just gives you that confidence to know that when you produce the part, it's going to fit and work exactly as expected. In terms of the 3D scanning element, is this something that you are doing in-house as well, or you are outsourcing that?
We do all that in-house as well.
What is the actual software that you've settled on for your product design and development?
So we use SolidWorks mainly, and SolidCam for post-processor. They work in really well together. But we do use, for some of the more basic machines, we came from a Fusion 360 background, but when you get to the point of starting to run, 5-axis mill turning, obviously 4 and 5-axis sort of sims on really expensive machines, you really kind of need to spend a lot more money in some decent software. Not saying that Fusion isn't decent, it's a really good entry-level software, and it's great for all our juniors and the vertical 3-axis type machines and the simple turning machines. But then, you really kind of need to step it up when you go full volume sort of manufacturing for some more expensive software. And it is a lot more expensive, and you pay per seat, and it's really not cheap.
Sure. I mean, I guess that's the difference. So the Fusion 360 has obviously become very popular in the enthusiast market because for personal use, it's essentially, for the most part, basically free. But that's far removed from what you're doing. So obviously you have to choose the software that's suitable for your particular application. Now, you used the term post-processing just before. Can you elaborate a little bit on what you actually mean there? Because a lot of people would think that once you've designed your part in Fusion or SolidWorks that your job's done.
So that's half the job. Getting it into a machine uses G-code. So G-code basically tells every axis how far to move or what to do. Then you've got to incorporate spindle speed feeds and cutting feeds and speeds and all the rest of it. So the post-processor basically allows you to simulate a cutting tool path on your part from your billet. And then it tells the machine how to move which axis in what direction and what speed with all the rest of it. There's a software that you generate called a post-processor, and that's what tells the machine how to use what you've done on your model and how to select the tools and the types of tools that you're going to use. And you might want to use a drill or an end mill or a tapper or whatever. So you've got a whole tool list, and that's what you use to program the machine to get it to cut that job, whether it goes from roughing to tapping to finishing to any of that sort of stuff. It's all coded on this post-processor, which arguably is the machinist's job, and the designer usually doesn't get into that. It's basically what is now a fitter and turner type machinist role is now a camming role to be able to get the machine to do what you've got on your screen.
Okay, so that process of turning your model into a toolpath, how much automation is involved in that with the software versus input from the actual machinist?
Look, both. There's a lot of automation that you can choose to obviously generate toolpaths from the machine. But to give you an example, you might want a different pattern. And I know it sounds simple, but to a machinist, and this is an argument we have in the shop all the time, to, the qualified machinist, they might want really straight lines and linear and smooth finish. And then, one of our QC guys will grab a part and you go, that doesn't look right. That looks crap. And you might well, hang on, you need to see the machining marks. And the machinist is going to go, no, you don't want to see the machining marks. A nicely machined part has no machining marks. What do you mean? It should be mirror finish. No, we want to.
So this is coming down to personal preference on the finish level that you want.
Absolutely. But just in the type of finish in a small section, you might have an infinite number of options on how to toolpath it to end up with a different finish. So yes, it is controlled by a human at the end of the day, and there is a lot of hours in getting each one of those finishes right. He still needs to pick the type of tool and how to toolpath it in each and every section. Obviously, to get the job run time down, you might want to go for a more aggressive, face mill or a face cutter or a bigger end mill and run it harder and faster. All that is up to the machinist. Once they've picked the tooling and the speeds and the feeds, and then you can get the machine to go and accurately simulate that particular toolpath given the information you've supplied it. It's a hand-in-hand process that is basically, it comes down to the experience of the machinist to get the software to do what he needs it to do, and knowing the shortcuts on how to make that job work out faster, because you can run a diff hat, for example, for 40 hours on a 4-axis machine, or you can run it in 3 hours on a 5-axis machine, but then you've got to start weighing up the options of what costs more, the time that the machine, the monetary value or the financial payout that machine needs to accrue in a job to make it feasible. That all comes up to different levels of management and what's happening on machines at a time. It's like coming into our shop and seeing all this happen. If you didn't know what was going on, you'd say it is absolute organized chaos, but chaotic. But all of that does come down into it, and it is a very fine art at the end of the day. There's a lot of moving parts. So yeah, it all has to work hand in hand.
Another element, I just wonder what you can tell us about from the uninitiated, maybe someone who's just got a copy of Fusion 360 and they've sort of figured out just by trial and error that they can make a pretty part, whatever that may be. I think there's an assumption from those who are fresh to this that if you can design it in Fusion 360, then you can make it, and that sadly is not always the case. And then even if you can make a part from a 3D model, quite often, at least as I understand it, this isn't my specialty, but as I understand it, for sometimes a couple of slightly subtle changes to the design can dramatically reduce the complexity involved and hence the cost and time involved in actually machining that part. So how do you keep this in mind from the outset when you're actually designing these parts to ensure essentially that A, the part can be manufactured, and B, that it can be manufactured at a suitable price point so that you can have a product that you can make a margin on?
It really depends on what part you're designing and manufacturing. And a lot of the time, if you just want to bang out a prototype and make it simple and then evolve it with revisions as you start making more and more batches, it's one way to do it. But if you sort of want to get it perfect the first time for a cam cover, for example, that could be one guy sitting there designing for 3 months to get an Evo cam cover to look perfect, and then camming it, toolpathing it, and making it really efficient is the way we might do it, because we know we're going to make eventually 1,000 of them. So you might want to do it that way for the first time. But if it's something that you're quite not sure if it's going to really take off, or you're committed and you don't really want to make it anymore, or you're bound for some reason, it's like, yeah, you might shortcut it and make it a slow way. It's only a slow production run and you're not dialing it in, and you might have a few burrs and you might have a few, tool marks that might not be perfect, but that's sort of good enough for that particular job. It's a conversation that has to happen, and QC will obviously pick it up, but yeah, 1 or 2 or 4 people might get involved in making those decisions on the fly. But yes, it is all crucial, and it all comes down to what you're trying to achieve and how many of those parts you feel you're going to make to warrant the time having a machine down while you're prototyping for 3 weeks that usually makes you $10,000 a day, and you're basically down hundreds of thousands of dollars to get the prototype out. It all comes down to the resources available at the time, what else is happening, how many people are screaming for other parts, and obviously the necessity that drives making the job in the first place all comes into play. So yeah, it's not a straight out easy question to answer.
No, of course. What you've just said there kind of leads me into another question in terms of what you do about deciding on the parts that you're going to produce. So whether that's driven by customer demand or you're physically seeing holes in the market, products that aren't up to the sort of level that you want them to be. And then from there, even if you've got the best idea for a product in mind, how do you sort of figure out if there's a big enough market to actually sell enough of these to make them worthwhile?
I guess I'll answer this one by telling you how we used to do it as opposed to how we do it now. How we used to do it was someone saying, hey, why don't you make a billet cam cover for a Ford Barra? And it's like, yeah, that's a good idea. Let's make that. And it might not be in line with what you're trying to achieve, where the business is heading and the engines that you're sort of focusing on at the time. So before, you'd go and make it and just see if it sells. We can't afford to just go and make it and see how it sells now. So there's a whole feasibility study that happens on every part. And it might be someone saying, hey, we need a cam kit for a trigger kit for an Evo because no one makes a good one. And it's like, yes, but what about the 500 other prototypes that we're working on? At what point, who decides what? And because this is such a hard thing to gauge, we've gone and done spreadsheets on feasibility. All right, it's a Toyota 1J, whatever. How many did they make as opposed to the 4G63? Let's have a look at the countries they're in, the demographic, the money that people have to spend in that country, the racing scene, how big is the market, how many we're going to sell, who are our competitors. It gets really complicated. So yes, you'd go and make a coil kit for a B series Honda, and they're not a big seller. The K series, we sell heaps of them. Like, how do you work that out? There's no easy way to work that out.
Can you ask the customers, or is it a case of they don't know what they want or need until it's available?
Yeah, but then all of a sudden, you'll get some guy that tells you a 4AGE coil bracket, you're going to sell millions of them because there's thousands of them everywhere, and it's just like,
and they want one.
Yeah, and they want one, and then you sell one. So now we've gone about it a completely different way. We go and pick an engine model to do everything to. So RB is just our staple. We make everything that we come across for the RB, and it's all queued well into a year from now, and we know what we're doing, and nothing takes precedence over the RB development platform. But then we choose the next one that we're working on in the background, and at the moment it's the 4G63, because we've got 5 big customers. We've got Mixed Motorsports, we've got HD Tuning in America, we've got ERS Performance in Sydney, we've got all the big guys that are working with us, and they're all buying these things, and they're like, okay, we need cam gears. Cool. We're working on cam gear. We need an engine brace. We need a trigger kit. We're doing a mechanical fuel pump kit, changing it, we're putting it on the inlet cam, MyVec cam sensors. We're doing all of it, and we go and prototype that whole engine platform at one go. We release things as we finish them, of course, but it's all in line with marketing that particular engine type to be able to cover it. And then all of these shops that are buying a cam cover or a cam gear or whatever in PRP gold or green or whatever it is, it then leads on to people wanting to buy the next bit and the next bit. And then we'll go and release, we do the billet transfer cases with high-speed engineering. We try and cover the whole engine platform because there's a hype happening with us and on our SEO and with all our clients about the 4G63 going nuts. So are we going to go and make a harmonic balancer for a Honda Civic whatever when it's not in line with our goals? No, we want to develop the whole engine platform, which leads me into, instead of creating, we were going to do the SR20, do we do all the vernier cam gears, all this stuff's we made a trigger kit. No, you know what, Mazworks makes one. Why are we going to go and redevelop stuff just to make it our own on an engine that's already $10,000 before you go and get a solid, lifter set up with a VVL? You're spending 15 grand on an engine. Why don't we create a market? So now it's like, hang on, guys. Let's work with the Americans because there's such a high demand for something different. Screw the SR, let's go the KA24 because you know what? You can buy an engine for $300. So then we do the billet cam cover. We work with Artec on the exhaust solutions. They're doing, they're working on intakes potentially on that engine. It's like, is it available? No. Can we create it? Yes. Can we create a market for it? Well, let's give it a go. So we work with Kelford on the cams, Peter McDonald that, does all our head flow design ports the head and works out the CFM and all the rest of it, that's airspeed and all that. Then we work with Kelvin and say, that cam's too big, this one's too small, we need something right about here. They're already a shim over bucket set up. There's no rockers to fall off or any of that sort of stuff. It's got a great stroke displacement. It's all there. We make all the new timing gear for it, the billet cam cover with the coil kit, integrator trigger kit, and all of a sudden we've got a $15,000 engine package, make 1,000 horsepower on a KA24 engine that you can pick up for $300. That's where we need to be. Forget the SR. That's how we create feasibility. We decide that we are strong enough now to create a market on a new platform that no one's really done properly.
Rather than trying to climb into a market where there's a heap of other competitors.
Yeah, and the competitors are overpriced and everyone's sort of doing that. So, yeah, we're trying to get the guy in the backyard to go and throw, something different, a forklift engine out of a Nissan whatever with a KA24, basically tear it back to a block, a crank and a head, and we get Italian rods and pistons to go and make the pistons and rods for it. No one's done it before, but yeah, it's going to be a volume part. And then, yeah, you can go and build this Datsun 120Y in your garage and end up with 1,000 ponies for not a lot of money. I'm into that. I'm a car enthusiast, so are you. We could, that sounds cool.
Sold.
Yeah, absolutely, man. Yeah.
I do like the aspect you were talking about, though, with even the more mainstream engines like the 4G63. You're dealing with specialist workshops rather than the individual end user consumer and asking them what they want. These shops are telling you what they see on the daily, and if they tell you, hey, we need XYZ part, you can be pretty confident that they're going to then sell 10 of those the next month and the next month. Yeah.
And they're going to buy them. Yeah. And if they had a hand in developing it and helping you test it, because it's not something that, we don't have heaps of Evos lying around, but heaps of workshops do, and they have a part in developing it for you, and they say, hang on, this hits, this is a problem, I can't quite get to the tensioner or whatever it is, then all of a sudden they had a hand in the development, and obviously they're locked into a slightly better deal than the average Joe on it because they helped, but they're a lifetime buyer of that particular part because they know it, they love it, they had a hand in it, and we made it happen for them. And if one workshop that is killing it with the 4Gs starts using it, you know what? The rest of them follow. So, yeah, it's a working situation, which each of those workshops.
Let's talk a little bit about the development and validation of the parts. One of the benefits of using the likes of SolidWorks or Fusion 360 or any of those software packages is the ability to do some pretty smart analysis of a design before you ever commit to actually producing. I'm talking here about finite element stress analysis just as one example. And I mean, not maybe all of the parts that you produce warrant going to that level, but is this something you leverage within that software or CFD for example?
Absolutely. And look, let me put it this way. I built, and Hawkins always has a go at me about it because I built an engine testing rig that I used initially to twist test engine blocks to be able to test the different braces available to make ours better when it comes to twisting a block and trying to get it to stay straight. And then all of a sudden you've got load cells, you're pulling it, you're getting data, you're giving it a certain amount of tonnage on one axis to twist a block from a certain angle and trying to simulate what's happening in the car. And you're trying to set the rig up to pull from the right angle to work out where the block's twisting from its center of mass and structure, and can work out how far out the tunnel goes and what the crankshaft has to do. And everything sort of starts to make sense, but it's a lot of work and it's very manual. You're setting up dodgy rigs and testing points for micrometers and dial gauges and load cells to be able to give you this data. Or you know what, there's software that just does it. You just tell it where it's going to apply the load from, and you can get this blue thing to twist, and you can apply 1 ton, 4 ton, 8 ton, 20 ton, 100 ton, and you can see it change colors and where the stresses happen.
Yeah, sounds a lot easier for sure. Heaps cheaper too.
A lot cheaper. So, we do that when it comes to trying to get parts to way less because the top end racers are going to want to have that part way less. Rob from CRD with Jordan, is like, we keep breaking front diffs off our four-wheel drive dry sump setup. So, all right, cool, we'll make it. And then you go and make it and you go, all right, that's going to be good for the load. And then they're like, hang on, how far are you going to go with this thing? It's like, we're in this other car that we might be building, I don't know, 3,000, maybe 4,000. Hey, if you can give me 5,000 horsepower, I'll steer the thing. Cool. So am I making it for 2,000 or 5,000 horsepower? I don't know. make it strong. And then you make it, and so, all right, you twist test it, and this is going to be good for 5,000 horsepower, this much load, driving 50% of it to the front, and you hand it over, Herman, that's too heavy. And you're like,
it's hard to keep people happy, right?
But without that software, yes, and we can always take weight out, and we always go back to the drawing board and do that and revise it and make it work. But without that software, we'd be fairly well screwed, because if a diff blows up at 200 mile an hour and you've got some Borkai behind it trying to steer this thing, not hitting a wall or flipping or whatever you're doing, if a drive shaft comes loose, there's a lot that comes into it. But without that software, man, we would be well and truly screwed, to put it that way. It's crucial.
Yeah, fair. I want to talk about some upcoming products. And we did sort of have a quick chat before we started this recording. From my casual observation, one of the parts that seems to be missing from your lineup, which would fit nicely with everything else you do, is a billet alloy block. And those have been making a lot of headway in the last 5 or 10 years. You've seen a lot of the top end drag racers sort of transition away from the factory cast block because they're not strong enough, and billet alloys kind of become the go-to if you want to make 3,000 plus horsepower from a VR38 or a 2JZ or anything else for that matter. But you're not going to do that. Let's talk about what you've got in the pipeline, if we can.
Yeah, look, we get asked all the time, can you make a billet block for an RB? Going, yeah, hell yeah, no problem. We can punch those things out. We've got the gear to do it. No worries at all. Are you going to do it? Hell no, I'm not interested in billet blocks. Bullet's doing a good job of billet blocks. We sell a heap of billet blocks. That's all Darren's. I promised him I'd never go near it, and I meant it. I'm interested in the 99% of the market that doesn't want a billet block because they're not a top-end dragger. Or, I know, you can run a billet block on the street, 1,500 horsepower, but it's just not a turnkey solution. It's a race engine. You want to go circuit racing, top-end drag racing, you need a billet block. There's no doubt about it. But you've got thermal expansion issues, and there's a whole heap of other dramas that come into it for your everyday streeter. I always tell people the difference between a street car and a race car is your wife's pregnant, she's about to pop. She says, we're going to the hospital now. You've got a Toyota Yaris in the garage with no mods, and you've got your 1,500 horsepower billet block RB. Which car are you going to get into to get into the hospital in a hurry?
So if you've got the sort of 45 minutes to warm up the oil and the coolant, well, that's a different deal. I'm interested because this is a conversation that does come up quite frequently about pros and cons of billet blocks. And you've mentioned thermal expansion of the billet block. Absolutely, I understand this is a concern, a potential issue. But on the flip side of that, if we look at an existing SR20, for example, we are dealing with a factory cast alloy block, not billet. For all intents and purposes, I would have assumed that you're going to have relatively comparable thermal expansion coefficients between a billet alloy block and the cast alloy block. Hence, my question is, where are the actual differences, and why is this a problem with the billet blocks?
So, common misconception there is aluminium and alloy are two different words, and they mean two totally different things. So a billet...
I will just clarify that I am quite careful with my wording, and the reason I am is because, as you'd well know, we've got aluminium and we've got aluminum. And I deal with the US market, I deal with the rest of the world, and no matter what way you say it, you're going to be pulled up by someone because you're saying it wrong. So I typically will stick to alloy to get myself out of that hot water. So I just wanted to clear that up.
Yeah, absolutely. It's a safe way of putting it. But at the end of the day, a cast aluminium means usually it's a cast alloy, which means it's mixed with a heap of other metals. Now, not getting into the specific metallurgy of all those different metals, you can get a cast alloy to be extremely stable, and billet is not. The thermal expansion on billet, for example, in an RB, you can grow a whole compression ratio. You can grow 40 thou on the deck between 0 degrees and 60 degrees Celsius, for example. Your main journals, you can grow 2 thou on your main journals. It's huge. It's not even comparable. A cast alloy, you can get cast alloys in the same realm as steels or cast irons or any of those sorts of metals. And it all comes down to, as I say, the metallurgy and what you mix in those alloys with. But a cast alloy is as stable as a cast iron, and you can get negligible thermal expansion, which means your SR20, you can get in it hop in it, start it up, warm it up as much as you would any other alloy block. Actually, you treat it like a normal cast iron block. They are that standardized and they are that stable is the word I was looking for again. So it's completely different, not even comparable. So when it comes to me wanting to appeal to the masses of the 99% of people that want an aftermarket block to go racing with but still drive it on the street, I'm not saying you can't do it with billet. Sure, you can do it with billet, but it's a lot easier to do it with a cast block that may hold 3,000 horsepower, and you might be running 500 horsepower, but the block, if it's strong enough because you've made the right changes in the right areas, and I'm not saying that, and people always say this and it bugs me, Nissan did a crap job of casting it. No, they did a great job. 208 kilowatts at the flywheel was all that thing was ever supposed to make, standard, and it does that tenfold, you know what I mean? So fit for purpose, the design's awesome. But when it comes to us as an aftermarket manufacturer, yeah, I want people to be able to upgrade their block or their cylinder head that you can't now buy from Nissan and have a turnkey solution. You can port the life out of it or leave it standard and appeal to the masses. And if that includes a cast, whether it be cast iron or cast alloy block or whatever it is, that you can street drive, thermal expansion's not an issue. You can set it up like a daily driver on spec, OEM spec type bearing clearances, and or modify the crap out of your engine and put a pro mod on it and make your 3,000 horsepower, whether you want to street drive it or not, but out of the same platform. The versatility of being able to achieve whatever you want with one casting machine, different, but sure, whatever. I mean, that's worth its weight in gold as far as I'm concerned. So that's the direction we're heading.
Okay, that makes a lot of sense. The thermal expansion coefficient of the material is probably something that is very easy to overlook, and I think most people without sort of any idea behind the metallurgy would assume incorrectly, as you've just pointed out, that aluminium is aluminium and hence billet or cast alloy is going to react the same. And I mean, clearly the fact that our factory SR20 block doesn't need to be warmed up to complete operating temperature before you try and leave the pit suggests there are some differences happening in there. Now,
before you get into that, there is a whole heap more into it that you can go when it comes to thermal properties of a billet block. It conducts heat a lot better than a cast block. So a cast block will keep the water temperature in its area and it'll try and keep the oil temperature in its area. And Nissan manufacturers might have, oil to water type coolers, for example. So they might want to equalize, they'll use thermostatic switches, but it keeps it very separate. With a billet block, because they do conduct so well, it's like you can't help but get your oil too hot. And it takes forever for everything to warm up because you're warming up all your water and all your oil. You might as well mix the things. I mean, it's just, there's a lot that comes into it. So when it comes to race teams, for example, that have unlimited budgets, like Koenigsegg building sub 100 hypercars a year, or Honda making a Formula One engine, or Cosworth, or McLaren, or whatever, making a Formula One engine or a hypercar engine, unlimited budget. I mean, you could go and make a billet block out of titanium for all I care. You could go and spend $4 million on a block. It doesn't matter. These guys are still choosing to use a cast aluminium, for example. That goes to show
there's some benefits in there.
Well, absolutely. There's a reason to it, and it doesn't come down to the budget. It's really expensive to make a cast version, but people always think, for example, cast is just cheap shit. No, it's really expensive to tool up. Sure, you might be making them cheaper once you've spent millions of dollars tooling up for it, but there's a reason why these manufacturers still go to a cast alloy over unobtainium when they do have an unlimited budget. So it takes a while for that to sink in a little bit. And you know what? Makes sense.
I would say you're onto something here, and the reason I say that is because Dart at PRI, or SEMA I think it was, last year announced their, I don't know if they've made it yet, but their cast iron version of the 2JZ block with all of the upgrades to make
I've got a little video on that I'm going to post, by the way. I walked past that block.
Yep.
And I thought it was an iron block, and I thought, these guys are creaming it with this, and I'll walk past it and I'll go and tap it, and it's a plastic print.
Well, they actually threw that to me, and I freaked out until I realized that it was 3D printed plastic, which I was grateful at the time because that would have really hurt. Hadn't really processed at the time that the guy must have been a bit of a madman to be able to lift and throw it at me. But anyway,
You'd still have a dent in you.
Yeah, wouldn't have ended well. But I mean, obviously there is a market there between, for the 2J in that example, the factory block has its known weak points, particularly the cap's probably one of the first places to fall to pieces. And then the guys making 2,000 plus horsepower in a Jag application, most of them now are transitioning to billet, but there's this sort of nice in between market, particularly for those who still want to street their cars. And it sounds like you're on the same line there. Now, I'm interested, what would drive you towards using an aluminium alloy for that casting versus cast iron? I mean, obviously there's a weight deficit, but what other considerations are in there?
Well, I mean, weight is probably one of the major players. I'm passionate about my cast iron. It does the job. It's really strong. I'm not saying that you can't get a cast aluminium to the same spec. I mean, you can cast 20,000 MPa in an aluminium if you want. I mean, it's all there. It's available. It's too hard. But the advantages that you have usually you have advantages with a cast iron because you can pour a cast iron block, bore it, torque plate, bore it and hone it and have a finished liner, a sleeve, it's ready to go. With an with an aluminium block, or a cast alloy block, I should say, correcting myself, you've usually got to throw in a liner. But there's all this new technology these days throwing in an alusil or a Nicosil type bore, which then you can put your piston straight into and have a finished product, and they are quite durable. So there's pros and cons to both. Manufacturing them for a street application, I'd be inclined to run a cast iron block in a street application, and up until 2,000, 3,000 horsepower, you might choose to stick with a cast iron. At what point would you flick over to a cast aluminium block? That could be 1,500 horsepower. Do you need it in your street car? We don't know until we go and make them and test them and get amongst it and see what the benefits are from an aftermarket casting point of view. But I think there's probably a market for both, and they both really need to be testing because there's so much that you can do with computer analysis and CFD and structural analysis testing. And there's so many opinions, and even within our crew, you might have a split decision in the engineering department on whether it should be cast alloy or cast iron. There's features and benefits and pros and cons of both.
One thing that I'm interested to get a little bit of your feedback on here, because I haven't really had the chance to dive deep into this, but when you're talking about the cast alloy block and using a Nicosil coating instead of an actual sleeve inside the block, and I mean, I know this is a technique that's common in the OE world. For those who maybe aren't following here, we can't run the rings directly on the aluminium surface. It's just going to wear the alloy too quickly. So that's why traditionally there'd be a sleeve or liner that is what the rings run on. So when you run just a full cast alloy and then you put this Nicosil coating on it, that gives the hard surface for the rings to run against. Now, I would have thought, or assumed, I guess, would be the correct term, that you still wouldn't have the rigidity and strength in that alloy, Nicosil coating or not, to cope with the extremes of cylinder pressure that we'd be seeing in an engine that would warrant going to one of these aftermarket cast alloy blocks in the first place. Now, obviously, there's elements that come into this, including how thick are you casting the cylinder walls. Obviously, you'd go thicker than a factory block, but why this is kind of a red flag for me, I guess, is it is one of the failure modes that we see with factory cast alloy blocks. They split the sleeves at extreme boost levels. So what can you tell us about this? Is it just what I said, the sleeve thickness that you deal with that, or the alloy that you're using?
Yes, it all comes into it. But for example, when it comes to an RB in a cast iron situation, you might have seen some of our videos, it all comes down to how much bore material you have as to where it's going to balloon, as to where it's going to split. And if you split it in one spot and you throw a liner in because it doesn't have the ductility of the liner will expand. And because there's no support behind the liner, because you've got a crack or a weak bore and it cracks in the same spot, that's the issue you have, unless you cement fill the thing, but that's obviously that's a Band-Aid solution. So if you can go and forget the standard SR20 bore that might only have 5 millimeters of cast alloy material behind the sleeve or behind the liner to give it the support, but you could give it 8 millimeters or 10 millimeters of material and then strengthen that, make it rigid, And then, for example, in an aftermarket sort of scope, because you would have to go and then torque plate, bore and sleeve your aluminium before nickel-sealing it, which would be something that the OEM manufacturer wouldn't do, but we could do, giving the bore the support that it warrants a big horsepower application. Well, all of a sudden you start fixing some of these wrongs that don't automatically apply in the high horsepower performance world, but you have the ability to do so. And so would OEM, but they've got no reason to go and make a block 2,000 horsepower rated when it was only ever designed to, going back to what we said about Nissan before. So yes, all of it comes into play. And as an aftermarket manufacturer, when you can simply choose what you want to do, the reason behind it, apply it, go and test it, have fun with it, it all comes down to being versatile, because you're setting the ground, or you're getting rid of the parameters that lock you into a certain series of events, because you can go back in time, so to speak.
Yeah, rewrite the rule book to suit yourself. One more question along the same sort of vein, and it probably is just ultimately going to be the same answer here. I mean, another issue that I would have in the back of my mind, very hard to really validate, I guess, without doing a before and after dyno test, but I'm talking to some of the engine builders and tuners who do the likes of these pro mod engines, very high specific power levels. Even if you don't have a catastrophic failure of a sleeve, a crack where that's it, we're done. What I can only imagine is that in the line or the sleeve, nickel coated or whatever it may be, at very high boost pressures, cylinder pressures, we're going to actually see the sleeve, the liner flex, and that's going to affect ring seal and hence blow by and the ultimate power. So that compared to maybe running something like, when I see in our billet blocks that everyone makes, they'll run something like a Darton ductile iron sleeve, a full sleeve that goes in there with potentially a lot more rigidity. Is this an issue? Or again, if you design it right with enough wall thickness, the flex is not going to be an issue?
I think if you did both, for example, design it for a nickel type, and there's three types of coatings. You can get an alusil, a plasma, and a nickel. They're all different. They're all very hard. They all have certain areas where some manufacturers are better than others. But for example, Lamborghini might do a 4,000 horsepower block. Well, it'll cop 4,000 horsepower with a nickel or an alusil that usually might not work for another manufacturer. It all comes down to, yes, how big that material is behind the liner and the metallurgy behind the components they've chosen to melt and throw into a casting. But if you make it, for example, thick enough to support a coated type liner, like nickel or whatever, and then, for example, you did do damage because you dropped a valve or whatever and you damaged a bore, to have the material and the design inherently from the beginning to be able to machine it out and throw in one liner, sure, or sleeve the whole lot. If you can do both, then you eliminate the issue at the get-go. And if one doesn't work in testing and for some reason you work out that nickel is not going to work past X amount of horsepower, and you can then at that point rate it to off the shelf, do this. And then if you want to go for that, with methanol, we recommend you run a sleeve, which is a nice thick sleeve. It's not going to balloon as much as a thinner sleeve, and you've got the material to support it behind that. It's not going to drop. It's not going to leak. You're good to go, because you've already designed it into the basic model. Well, do both is what I say. We don't know yet.
Fair enough.
Yeah.
I mean, it sounds like it's pretty early days for this concept, but have you got an idea in mind, without teasing our listeners, as to when these sort of might break ground, or is it way too early to even know?
Look, people ask a lot, and I get it. I don't want anyone to hold up a build because we might be close, but we hope to be testing both an RB cylinder head and cast iron block within the next few months. Once we're a little closer, definitely, I hope to have something well and truly tested by the end of the year. I'm not going to say we're going to be ready to release by the end of the year, but we are pushing really hard to at least have some news or something on display, even if it's just a little casting sort of test jig that we're sort of working on at the moment, available sort of at GTR Festival. But if we don't turn up with something cool to have a look at there, we'll definitely have some news out by then on some progress. But yes, we are well and truly into pattern making, casting, testing, tooling, specific tooling, because the aim of the game is for us to sell by the end of the year, hopefully, if not sometime in early 24, is a finished RB head, machined, clearanced, even built if you want it, a machined, ready to go block for your engine builder to go and assemble.
In terms of that cylinder head, I can only imagine that if you're starting pretty much from a clean sheet of paper design, I'm assuming here you're going to want to retain the geometry of the stock head in terms of bolt patterns, so all of the rest of the aftermarket gear still bolts on. But I can only imagine that's going to give you significant flexibility in redesigning the ports to something that is better flowing, because let's be honest, the RB26 cylinder head, while I love them to death, they're dated. They're getting on a bit. So is that another benefit with going with a clean sheet of paper design?
Yeah, so I'm happy to talk about it. We've had Peter McDonald, arguably, one of Australia's sort of top RB porting gurus, working with us, and I think there was a time there for about 3 months back to back porting particular ports and cylinders in heads, just one at a time, to try and get the airspeed up and the flow up, the CFM to increase while not compromising airspeed, and going to the flow bench and checking it. And then it was back to back, day after day. It was relentless, and I'd get a phone call from Pete one morning saying, man, I reckon I've hit the best combo with this port. It is amazing. I've outdone myself. And being able to port it beyond there being material there. I mean, you can just get it to a paper thin if it needed to be in one direction over another. And he'd go, I've got it. And he'd go and come back. I lost 10. I lost 10 CFM. Or I got my CFM up, my airspeeds down, or my short turn, blah, 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 technical. Pete, try again tomorrow. Yeah, I know what I've got to do now, and I'm going to do this, I'm going to do that. And it's like, after months, Pete, are you sure you don't have this port sorted yet? He goes, yes and no, but no. And yes, but we'll keep going. So then to get the perfect port, what he thought was a perfect port, and then you go and reverse engineer it, CMM it, make plugs, scan the plugs, build it into a model to what he feels the perfect port should be for a stock head, and then obviously swell it and reduce it to suit the CFM that we want to offer as a standard head package, and then have 5 levels of CNC machined awesomeness after that. It basically, you get the biggest port, and we give it 5 millimeters around the whole lot, and then just downsize it from then on in to end up with a perfect sort of OEM port that flows more or less a little bit better than a standard port without having to modify it and take out the lump out of the exhaust and all that sort of stuff. Yeah, absolutely. We've done all of that, and we've put all of the thought process into it.
From what I'm picking up here, it sounds like the RB scene is far from dead in the water, and with these parts sort of come to fruition like you're expecting them to, I can imagine the drag scene with the RBs heating up even more than it has over the last few years. So it's great that there is still such enthusiasm for developing what now is, let's be honest, a fairly old engine technology, but I certainly look forward to seeing where that goes to.
It's very old, man. And just on that, I was at TX2K not long ago, and there was like 1,000 R35s racing, and everyone's got, you need an 8-second or faster car just to qualify with 1,400 horsepower. It's like everyone had one of them, or a Lambo or an Audi or whatever. Guess how many RBs I saw racing there?
Zero. Yeah,
not
I've been
one.
there, and I'd 100% agree. It's an R35 versus Huracan/R8 festival, really.
Yeah, and walking around the pit saying, hey, bro, you've got the wrong engine in that car. And they're like, what's this Aussie guy talking about? Well, the VR38, it's the wrong engine. You should be putting an RB in this. Going, what's an RB? Why would you know? Well, that's how we do it in Australia, because guess what? Everything that wins anything in Australia, sorry to say it and upset the JZ guys, it's an RB, man. It's just the way it is. So to bring the RBs, hopefully, over to America to show them how it's done with some, old school RB power that sounds absolutely amazing. Can't compare it to a VR38. I got to upset a few people there, but I think you'll agree.
No, I would 100% agree. The sound of the RB, again, probably getting a few people offside, but it'll take down a VR38 on the sound front any day of the week. Look, Herman, I know that you had some prior arrangements, so I know we're running a little tight on time, so I think we'll move towards wrapping this thing up. Otherwise, we could be here for another couple of hours, but do respect your time with us today. We've got the same three questions we like to finish up all of our podcasts with, and the first of those is, what's next in the future for you and PRP? I mean, obviously, we've just talked about the cast alloy blocks and cylinder heads, but yeah, anything else? What's the direction for the next 5 years look like for you?
So we've just gone and reorganized our tiny workshop. It's not big. We've got a lot, jammed in there. We've got an extra storage facility and moved everything that absolutely not crucial into that area. And we've jammed some new machines into our space. So where we're heading from here, we'd like to build a new workshop, give ourselves a bit more room to move, because we do need to order new machines and keep them coming to be able to substantiate, the RB platform with all the heads and blocks, and, we'll get into the JZs and the 4Gs. I mean, the sky's the limit. So I want to go to an OEM type spec manufacturing stage with their major components and be able to offer the whole lot turnkey. And then, someone wants to go and copy a coil kit. So what? Go and copy a coil kit. It's not the end of the world. We're still developed all those sorts of things. Obviously, that's our grassroots and where we came from. But from here on in, really pushing into the US market and forming alliances over there and getting a base happening there and stock and warehouse and all that sort of stuff, pushing into the US in a big way is probably our major concern over and above what we're working on right now, and the expansion that obviously everyone notices that we're sort of acquiring brands and pushing, if we can't make it, we'll go and do a deal with someone that does and go and offer it and support it and warehouse it. Yeah, it's on a huge exponential growth, and I don't know where it's going to end up in 5 years, but we'll see. We can't do any more to push it any harder. So that's our general direction.
Exciting times for sure. All right, next question. Is there any advice you'd have for a younger version of yourself to help reach where you are today in your career faster, or potentially maybe avoid some of the pitfalls you've experienced?
Look, I think if I could go back and talk to myself from an early age, I never really went to university. I learnt all of my acquired skills and went and did all my engineering after school by getting, spare tertiary educations and learning things the hard way and falling on my face 4 times in business and losing everything, and gone from having sort of liquidation after liquidation, getting really good with learning how to get myself out of trouble and in and out of courtrooms and all that sort of stuff. If I could go back in time and tell myself, you know what, bro, you really need to study business studies in some university or engineering and have that background first, it's going to save you a lot of pain. But learning it the hard way has definitely given me the skills to be able to conquer whatever I need to conquer. And being in those situations, in and out of frying pans, it gives you a certain aspect that you can't teach. So I guess my advice is to anyone that wants to go for it is just to go for it and get advice. If you don't know the answer to something, and I don't know a lot of answers, I'm no expert in most of the fields. In fact, I'm not all that bright at all. I go to someone that is. And if I need to get an opinion on some metallurgy, you know what? I'll go to a metallurgist. If I need website advice, I go to a web expert. And you employ those guys as business takes off. You start to bring an accountant in-house. Don't work out how to program a machine. I don't know how to do that, but I can hire some really good machinists that run rings around the guys that have come out of the automotive game that have learned how to program a machine, that do a really slow or crappy or not efficient job. You go and hire the gun that knows how to do that really fast and a heap better than you're ever going to be able to. You've just got to harness the strengths of the people that can do it better than you, and just organize the people around you to get your results done. And all you got to do is drive the plane and have the ambition to do it. And it all comes down to one word, is passion. I think it's just passion. Being driven and loving what you do gives you the perseverance to get up every day, whether you're having a good day or a bad day. You're going to get yelled, you're going to have to yell at someone or whatever it is, getting the job done. It all comes down to sort of passion and drive. And if you've got that, everything else sort of seems to follow.
I reckon that's a pretty solid answer there, Herman. I don't think I could have put it any better myself. I mean, your point about learning from what's been some failures, we obviously don't dive deep into those, but that happens in business. But someone could tell you that same information, but it's just like listening to your parents when you're young, and they'll tell you all of the things that you need to know about life. And you're old, and what would you know? I've got this, and then you look back in 30 years time, and mum and dad actually they knew what was going on, but you just can't be told. So sometimes learning from your own experience. The other point that I really like that you made there is, you don't have to have all of the answers. You don't need to be the smartest person in the room. Surround yourself with people that are smarter than you at the specific tasks you want them to do. And it's always easy to fall into the trap of thinking that you have to be the expert at everything. And that's just a recipe for doom and gloom, I think.
One more thing I'll add to that before you go. It's not just passion. Whether you're, having success or you're not, or you're trying, or you are successful, or you make it in life, or what your peers determine as you make it in life. My father always told me, always stay humble. Always have time for anyone that wants to talk to you, and stay humble. Never get a big head. Never big note yourself. Never let anyone know what you've got. Just let them know what you're trying to achieve. And stay humble, son. And I take that to heart, and I'd like to think that I'm humble, although I'm passionate and driven and excited, and I want to make it happen. And let's go and kill it, and let's make awesomeness work. It's like staying humble is really important to me, because you know what? No one person's better than any other person. You can have achievements, and you can have attributes that make you who you want to be. But at the end of the day, someone that is not humble and just thinks they're better than the other person, there's nothing more unattractive than that. And it would push people away from even wanting to do business with you, because they're not going to like you. I don't like the people that think they know it all and have a chip on their shoulder. It's not cool. So just stay humble, be passionate, and that's it, man.
Yeah, arrogance is never an attractive character trait. Right, last question for today, Herman. If people want to follow you and see what you're up to, where are they best to do so? What are your sort of social media channels?
Instagram, probably one of my favorite. I'm trying to get away from that and letting someone else handle it, but I just, I love seeing it all. I love being involved. I love seeing what's happening, replying to people on there, although I don't usually have the time. Instagram, Facebook is always strong. Obviously, we're doing a lot with YouTube on our own channel, and TikTok, we're sort of starting to get there with it. But Instagram, Facebook, and obviously download our app, PRP World app, that you can get on Android and Apple. And we have notifications that come along there, or get on our website, join the mailing list, and you'll get an email when we get a chance to get our monthly sort of emails, newsletters back up to speed. But any one of those, we'll see you, and we'll always reply, and thank you for following and liking.
Perfect. All right. Well, thanks for the chat, Herman. Really interesting to get some insight into the background on PRP. I'm really, really interested to see the outcome of this cast block, whether it becomes iron or alloy, whatever that may be. Certainly, as from the chat, sounds like it's a potential game changer. So we'll wait eagerly and see how that goes. But again, thanks for your time today.
Awesome, man. Thank you very much. Thanks for your time.
If you enjoyed this episode of Tuned In with Herman, we'd love it if you could drop a review on your chosen podcasting platform. These reviews really help us to grow our audience, and that in turn helps us to continue to get more high quality guests. To say thanks, each week we'll be picking a random reviewer and sending them out an HPA t-shirt free of charge anywhere in the world. This is also a great place to ask any questions you might have too, and I'll do my best to answer them if your review gets picked. So this week, a big shout out to Stuart Emmett from the United Kingdom, who has said, thoroughly enjoyed the 1.5 hours with Micah this week, another in a long line of brilliant guests. Every week there's something that I can take away from the pod, whether it be validating something that I already do or introducing a new view or topic. Andre's a great host, and you can sense his enjoyment throughout the interview. Great work, keep it up. Well, thanks for the kind words there, Stuart, and if you get in touch with your t-shirt size and shipping details, we'll get a fresh tee shipped straight out to you. All right, that concludes our interview. And before we sign off, I just wanted to mention for anyone who's been perhaps hiding under a rock and hasn't heard of High Performance Academy before, we are an online training school and we specialize in teaching a range of performance automotive topics, everything from engine tuning and engine building through to wiring, car suspension and wheel alignment, data analysis, and race driver education. Now, remember, you've got that coupon code. You can use podcast75 at the checkout to get $75 off the purchase of your first course. You'll find our full course list at hpacademy.com/courses. Important to mention that when you purchase a course from us, that course is yours for life as well. It never expires. You can rewatch the course as many times as you like, whenever you like. The purchase of a course will also give you 3 months of access to our gold membership. That gives you access to our private members only forum, which is the perfect place to get answers to your specific questions. You'll also get access to our regular weekly members webinars, which is where we touch on a particular topic in the performance automotive realm. We dive into that topic for about an hour. If you can watch live, you can ask questions and get answers in real time. If the time zones don't work for you, that's fine too. You're going to get access as a gold member to our previous webinar archive. We've got close to 300 hours of existing content in that archive. It is an absolute goldmine. So remember that coupon code podcast75. Check out our course list at hpacademy.com/courses.